Now, another one, so rather than surface area, another one is concentration. Concentration of reactants. Concentration of reactants. Now, in the textbook, as well as my demonstration to you guys, would be like this. Magnesium strip, solid, plus HCl, hydrochloric acid. This gives you hydrogen gas, as well as magnesium chloride. So in this case, you put that in, put a big 2 in front of it. St. J, can you close that door?
Yeah.
Thank you. Now, so in this experiment, concentration of reactants. I'm going to compare the two concentration. I'm going to use a weak hydrochloric acid, and I'm going to compare it with a strong hydrochloric acid. And I want you to see what happens, okay? And then we think about what can we do to design this experiment. So, okay, so you guys have saw the demo just now. Now, the different ways you could do, you can measure how long it takes for, now you can do two of these. You can actually do how long it takes for the magnesium strip to be gone, like completely disappear. You could do that. You could also do how long does it take to stop bubbling. When the reaction is done, it will stop bubbling. You have two different options. So that's one possibility. You can collect the gas, which is hydrogen gas, and compare volume collected over time. So you can do that. And in fact, that is the diagram in the textbook, figure 7.17. That was the reaction. They have the gas syringe and all. Okay. Now, because the gas is so light, you cannot do, cannot, look like carrot the way I wrote it, cannot do mass loss since H2 gas is light, too light. You can do as a plan B, not the best idea, but if you don't have any other things, you can do it. Plan B is a plan B.
What is this? Was this a smoking one?
What's smoking one?
Yeah.
That's you can see the constant. Well, it's just whether it's the one that generates smoke or the one that doesn't generate smoke. You can measure the rate of reaction by measuring temperature changes. You can compare rate of temperature change. It's just not a very, it might not work well. You might not get good results. So if you have if the equipment for the other two possibility are there, you should do those. But if you don't have those equipment and you have a thermometer, well, then stick with the thermometer. Then you do this plan B. Okay? Questions? There are some experimental design. They're just outright bad idea. It won't work. Like this one, it won't work. There's some experimental design. They are good, and you should do it right away. And there's some like, if you don't have the first choice, then you do it as plan B. And that's a skill you should you learn and develop as a scientist. Good so far? Questions? No? Awesome. So